Hello. So, as you can see, we have a differential equation, and this differential equation is the first order differential equation. Okay. So, why do I call this a first order differential equation? Because there is one derivative term here, so dy by dx. So, because we have dy by dx, only one derivative, this is the first order differential equation. And here you can see px and qx. You can assume them to be random functions. Okay, for now it's just any two random functions. But I will need them to be integrable functions. Okay. All right. So this is the first order differential equation. Let's see how we can solve them. As you can see here, qx. What I'm going to do is I'm going to make qx to 0. So I'm going to simplify this a little bit so that I can show you how to solve the simpler case, and then I will try to solve the complex case. So this is 0. So let's try to solve this. So how do you solve this? So you just basically bring this to the right hand side. And so dy by dx is equal to minus pxy. And then you bring y to the denominator. So 1 by y dy dx is equal to minus px, right? Now all you just need to do is you integrate both sides, right? So the minus sign comes out. So integration with respect to dx. And so what you have here is basically this. And so this term is basically integral d by 1 by y. Okay. Well, I've seen people do this. So basically you can cancel dx and dx, and that's how you get dy 1 by y. Well, it's not true. Okay, so there is no cancellation of dx happening here. So this is basically this particular step where you go from an integral where you can say you're integrating with respect to dy, and then your integral changes to with respect to dx, and so a derivative term comes up, right? So this is basically something called as a change of variable or substitution. So it's basically you write y as a function of x, and then when you bring the integral with respect to x, so you're basically changing the variable. You get a derivative term dy by dx. Okay. And so it's basically like you're canceling dx. It feels like you're canceling, it seems like you're canceling dx, but no, it follows by a theorem called as substitution. Uh, so so I will do that. I will do that, definitely. I will do that in my channel. So also when you integrate, you always have a constant of integration plus c. So this is logarithm of y. So what you have as logarithm of y is minus integral px dx plus c. Now, how do you remove the logarithm? Basically, you just take the exponentials of both sides. So this will become e to the power minus integral px dx times e to the power c. Well, e to the power c, I'm going to denote this as a constant a. So you have an a here, right? So this is what you get. Now, this is interesting because this is the solution of dy by dx plus pxy is equal to 0, right? But what I want to solve is a more general case when you have qx, right? So for this, what I'm going to do is I'm going to get inspired by this particular answer here. So you can see on the right hand side, it's e to the power minus integral px dx, right? Well, you can bring this to the left hand side. So it will become e to the power integral px dx y is equal to a, right? So what this tells me is that if I have something like this, right? It's something interesting, right? So what I'm going to do is I'm going to take this differential equation and multiply both sides by this particular factor here. So this is also called as the integration factor. So plus pxy is equal to qx e to the power integral px dx. Okay. You will see why I'm doing this. So this will become much simpler, because if you do this, what will happen is, so let me just bring this inside the brackets here. So dy by dx and plus e to the power integral px dx and then pxy. Okay, now this here is something which I want to emphasize, is the fact that you have this term here, and here you are taking the derivative of y. Here we have y, and here I have something, right? So let's try to differentiate e to the power integral px dx. Well, if you differentiate this, what you're going to get is e to the power integral px dx, and basically you differentiate this term, right? By chain rule, you differentiate the integral. Well, differentiating integral is nothing but the integrand, which is px. So that's what we have here. So what does this tell me? This tells me that this whole thing is nothing but e to the power integral px dx dy dx plus this is the derivative of e to the power integral px dx, and then outside we have y, right? So this is a function, and you're taking a derivative of another function plus derivative of the first function multiplied by the second function. So this is nothing but our product rule for derivatives, right? Yeah, I've changed the cross notation to dots. Yeah, so this is nothing but d by dx of product of two functions, so e to the power integral px dx and then y, right? So just the product rule. So let me write down. I know you all cannot see my screen. D by dx e to the power integral px dx times y is nothing but, if you go up a little bit, so this is qx times e to the power integral px dx. So let me write down. So qx times e to the power integral px dx. Now, how do I solve this? Well, you just need to integrate both sides. Now, if you integrate the left-hand side with respect to dx, which you get as e to the power integral px dx times y. The right-hand side is basically integration of qx, and then e to the power integral px dx, and then there's another dx, and then plus, always there's a constant of integration. Never forget the constant of integration. Okay, I must emphasize here that that the variable here is x, here also is x, and yeah, it's perfectly okay here. Okay. Okay, I was thinking something else, guys. So, so y is equal to e to the power minus integral px dx, and then integration qx e to the power integral px dx plus c times e to the power minus integral px dx. So this is the solution of the differential equation. So your y, which is a function of x, is given like this. Okay, so this is how you solve the equation. Well, it's good enough, but I also want to show you an example, an application of this, the solution of the first order differential equation. Maybe I can do that in the next video that I will be putting. So, okay, that's all for today. Take care. Bye.